Okay. Sections 1 and 2 are law of sines, then law of cosines. Then we'll get into more vectors and applications using law of sines and law of cosines. So those that are either in physics now or have taken physics, this chapter will be pretty much a cakewalk. Okay? Those that haven't will need to work a little bit harder. But it will still be better than last chapter. Okay, we're going to start off with law of sines though. Now, law of sines and law of cosines, you're only going to use them on non-right triangles. They're also called oblique triangles. That's how the book will refer to them. But there are 4 different varieties that can show up that come into play when you're talking about sine and cosine. Okay? If you have angle, angle, side, or angle, side, angle, that's law of sines. Anytime you have 2 angles, you can use law of sines easily. Anybody remember what law of sines looks like? It's all 3 fractions that are equal to each other. Yeah.
It's like sine of A over A.
Yep, sine of A over A equals sine of B over B equals sine of C over C. Okay? So as long as you have 2 angles, you can basically fill in, because if you know 2 angles, you really know all 3, right? Yeah. So that's just to set up the fractions, find the side lengths. 2 sides and the angle opposite them, or opposite one of them. In other words, it'll also be called 2 sides and the non-included angle. That's SSA. You could also spell it in reverse. That's why it's the one that usually when they first introduce it in geometry, you're not allowed to use it because it's the cuss word. ASS.
Yeah, but
That's how I teach it. Anyway, later on, the reason they do that is because you can get a lot of weird things happening when that's all the information you have. That's what we call the ambiguous case. You can actually have 1, 2, or 3, or 1, none, or 2 solutions that are all work, depending. 3 sides, SSS, will work for law of cosines. That we'll talk about tomorrow. And SAS, the 2 sides and the included angle, again, we'll look at tomorrow. Okay? So, you can also flip the fractions. Okay? Since all those are ratios to each other, you can flip them over. I'll usually always set them up so I put the variable in the top left. That way you don't have to worry about cross, multiply, and divide or anything, but you can set it up however you want and solve. Okay? So, just to review. Now, I honestly, pre-calc, I kind of stopped drawing the triangles if I don't absolutely have to. For law of sines, law of cosines, as long as you're comfortable with how the angles are in relation to each other. Side A is opposite angle A, so on and so forth. You can run with it. If you still struggle with that, draw it. Okay? For this, though, I have angle A, angle B, and side A given to me. If I want to find the rest of them, the rest of the angles, rest of the sides, well, what's going to be the easy thing to find first? The last angle. They give me B. I would actually use angle C first. You could do side B, that's fine. But angle C would be what?
The usual. No. 105.
105.
Oh, God.
180 minus 30 minus 45, right?
yep.
Coming back to you after the 5-day break?
Very slow.
Okay. Now, to find side B, I'm going to put B in the upper left, which means what's going to be under it?
Angle B.
What about angle B?
Sine.
Sine of 45 degrees. Make sure it's sine of that angle.
Sine.
What's going to be the other fraction?
We can do A.
32 over sine.
32 over sine 30. So then you just multiply it. So B is going to be equal to 32. Sine 45 over sine 30.
Nice.
Which is going to give you what? Now for triangles especially, we're going to be in degrees. What do you get?
45.
Anybody else get that?
Yes.
Yeah. 45.25. What would be the units on that? Feet. Okay. So there's side B. What else do we have to find yet?
Side C.
Side C. So set up, same type of fraction. C over the sine of
105.
the 105 from earlier. So C is equal to what?
Oh, 32 is 915.
Yeah. What do you get?
I got 61 points. That's what I got.
61.8.
Yes, there it is.
Yeah. Make sure you're in degrees.
Yeah.
Questions? Okay. You also have quite a few word problems in these sections too, where you got to get a little creative with some of them. This one's not too bad. Because of the prevailing winds, the tree grew so that it was leaning 6 degrees from vertical. At a point 30 meters from the tree, the angle of elevation of the top of the tree is 22.5 degrees. Find the height. So, one like this, fill in what you know. Well, what do I know? The angle what?
Well,
Elevation. I just couldn't hear you. Angle of elevation is what? 22.5 degrees.
That's correct. And that point is 30 meters from the tree.
Okay. So M is 30 meters.
And that top angle, or no, that bottom angle, there you go, is 96.
It's 96. Since it's 6 degrees off of vertical, vertical would be 90. That would be 96 degrees. So if I want to find H, well, obviously I have angle side angle here. So if I want to find H, I'm going to put H over what?
The sine of 22.5.
Sine 22.5. Now that's going to be equal to,
30 over the sine of 96.
close,
No, that's wrong.
because the problem is 30 is not opposite 96.
It's not.
30 is opposite the angle up here.
Yeah. So let's do some math.
Go ahead and find that angle. What do you get?
61.5.
61.5. Go ahead and solve for H. Anybody else? 13.1? Yeah. 13.1. This angle's small enough, the tree's going to be not that, well, it's meters though, so it is still fairly large.
Big tree.
So about 40 feet tall. Questions on that?
That's a big tree.
40 feet?
Yeah.
No, it's not.
That's a big tree. Come on. We're not living out in the red oaks here where they're like hundreds of feet tall. Come on, that's a big tree.
We had a cottonwood in the backyard when I was growing up that was probably about 140 feet tall.
So that's a fairly large tree.
Yeah, but 40 feet, that's as long as you're not like living in a fairly new housing development with just
that's a lot of me's stacked on top of each other.
that's
a
how
big
you,
tree.
okay.
That's-
Anyway, moving on to the ambiguous case. This is where you have that SSA format, two sides and the angle not between them. Okay? Now, the book actually makes this a little more complicated than it really is. You're either going to have no solution, one solution, or two solutions. Okay? This is a good breakdown of it, but I usually don't think of it quite this way. These are all the different possible combinations you could have. Okay? So this is your given A, B, and angle A. So those three measurements are locked. Okay? If, well, A is acute, you actually have four different possible things. So I'm going to go to A's obtuse first, because that one's very easy. As long as A is more than 90 degrees, that angle A, then either you're going to have no answers or one answer, one possible triangle. Okay? The way to test that is just to solve it on your calculator. If it gives you an error, it's none. If it gives you the answer, finish it off. Okay? Here, this first one is also the same type of thing. These all four are acute. This is if this side A is actually less than what the height would be. Okay? The way to think about this, if you had a hinge here, this side would swing freely. It wouldn't be able to reach the opposite side of the triangle. Because this angle is locked in place, this thing would just swing back and forth. And that would be no solutions. Well, again, the calculator is going to give you an error on that first step. Done. Okay? A is acute and A is equal to H. Well, this one, well, what type of angle are you going to get for angle B when you do this? Right triangle. Yeah, so if you get 90, you have one solution. If A is larger than B. Well, if I think of that same hinge concept that I was talking about here, if you swung this back, well, there's no other point where this length would land on this line again until you ended up all the way over here somewhere. That's no longer the angle A. Okay? So the idea is if A is ever bigger than B, the opposite, the one you know, and the angle you know, the opposite, is bigger than the other side you know, you're only going to have one solution and run with it. This is the actual ambiguous case. This is where you could have two different possible. And some people have a hard time seeing this, but the idea is if that A is in between the length of the side the adjacent side you know, and what the height of the triangle would be, you can actually generate two different triangles. You can generate this one, where you have this angle A, this side B, and this side A, back to here. Or you may have this angle A in the bottom left again is the same, B is the same length, and A is that same length down to here. Both those triangles have those three properties, so they both fulfill those requirements. You need to be able to find both of them. Okay? So let's look at a couple of these oddball ones that are SSA. For this one, well, how many solutions am I going to have? Well, first off, is A acute or obtuse? Acute. So it's acute. And how are A and B related to each other? A is bigger than B. So the only way that's going to happen, because A is longer than B, there's going to be one solution. Okay? If you do out the problem, you get one solution, you're done. This one. Here again, A is acute. How are A and B related? Yeah, A is less than B. So this one might work. Or might have multiple solutions, so I need to check it. Okay? So, what would you find first? Angle B. The only thing you can find first is angle B. So I'm going to set this up. Sine of angle B is over what? 14. So you go to sine of angle A over the side opposite. Well, when I do this, and this is a step I'd usually actually skip, I'd jump straight to the next one, but multiply by 14, you get 14 sine of 60 over 4, and then what? Well, how do I find B? Don't overcomplicate this. How do you get B by itself? Inverse sine, yeah. So do the inverse sine of that fraction. And I type this all in at once on the calculator, so I don't have any rounding errors going on that could screw up or anything else. But when you do this, what do you get? Anybody else get an error? Yeah. This one has no solutions. And the reason is, if you actually stop and look at this, the 60-degree angle here is going to be about that. Where if this is the 60, this is 14, well, this would be 4. Think about that hinge point. This thing would just swing back and forth and never actually reach all the way down to here. So it's no solution. Does that make sense? Okay. This one, though, you still have A less than B, but now it's not so much severely less. This is one where you're going to have 2. You still have an acute angle. You have that A is less than B. But when I do this, I'm still going to solve for B first. So I have sine of B over 5 is equal to sine 58 over 4.5. So B will be equal to the inverse sine of what?
5 sine of 58 over 4.5.
5 sine 58 over 4.5. Okay. What do you get for B? Anybody else get that? 70.4 degrees? Okay. Now, the problem is, since A is less than B, and it worked, there are possibly 2 answers. So I need to stop and look at it. Now, you could actually do this with the other ones as well. It would just give you an error eventually with the second one. Because the problem is, my theta, my 70 degrees is right here. Well, where else, if I think about unit circle-wise, where else is sine, or where else is the result of sine of 70 going to be the same as that angle? What quadrant would it be in? Remember, sine is the vertical, right? Be in the second quadrant. So the idea is it'd be up here somewhere because you want that vertical y value to be the same. Well, how do I find that angle? Yeah, because theta is here, this theta is also here. Those are both 70.4 degrees. So if I want to figure out this from here to here, I'm going to do 180 minus theta. And it will always work that way. Take 180 minus theta, you get what for B? 109.6 degrees. So the idea is you could have either one of those and this would still work. Does that make sense? Okay. From there, you just figure out angle C. What would angle C be for the first case? What do you get? 51.6 degrees. And this one? 12.4 degrees. Now you'd still have to go through and find side C. So you set up your fractions and solve those out. But that's just the same old process. Questions on that one? Which part, Madison? Yeah, they give you A up here.
Okay, never mind.
Okay. Just the 2 B's are different. One last thing. Area of an oblique triangle. Now, this is a formula. I know we do it in FS&T. I don't know if they did it in Plus or not. But this is actually derived from the law of sines. That's why it's included in this section. Because if I want to figure out this height of the triangle, I could actually set up a sine ratio and get the height from taking B times sine of A. Just think SOHCAHTOA. Okay, if I have angle A here, well, this height then, sine of A is going to equal height over B, so that H is equal to B sine A. The base is always going to be that C side, no matter if you're talking about an obtuse triangle or an acute triangle. So as long as I know 2 sides in the included angle, you can find the area of the triangle. Okay, and you can just, well, it's a fairly simple formula to come up with, but you can use it no matter what, as long as all 3 letters are different. So it's kind of like the law of cosines as long as for how it works, because it only works when you have side angle side, 2 sides in the included angle. But it's a nice way to be able to find area real quick. Okay, so if I have area is equal to 1/2 AB sine C, I want to find the area of a triangular lot containing side lengths that measure 24 and 18 yards and form an angle of 80 degrees. Well, go ahead and do it. What do you get for the area? What do you get?
212.7.
Anybody else get that? Yeah. Be 212.7 square yards. And that's just literally plugging numbers in the formula. Now, one last, still using the same stuff, but we can't like throw out the bearing stuff entirely. We still got to keep it going a little bit.
No. We can throw it out.
I'm out.
On a small lake, a person swims from point A to point B at a bearing of north 28 degrees east. The person then swims to point C at a bearing of north 58 degrees west. Point C back to A is 800 meters, and it's due north of A.
Oh my goodness, he swam a long way.
Pretty good distance, yeah.
800 meters?
Well, that's not
That's a lot.
what he swam, though. He swam the other ones as well.
So he swam more than 800. Oh my goodness.
So,
This guy's an Olympian.
due north. It's not quite Olympian, but okay. From A to C is 800. This is one where I would draw it out. Okay, now, from this point A, how would I show north 28 degrees east? Which quadrant is that going into at that point A?
What?
The first quadrant. Now, is it 28 degrees up from here or 28 degrees right from this one?
28 degrees right.
28 degrees to the right. It's east of north, so it's 28 degrees here. So if I'm doing 28 degrees here, the person swims for a while, stops at B, reorients, and swims towards C at a bearing of north 58 degrees west. So the idea is I'm going to draw that axis again so I can see it. Here is what quadrant relative to B is north 58 degrees west going to be?
Second.
Second quadrant. So it's going to go from here up to here. And the 58 degrees is going to be right here. Okay? So that's all the information they actually give me in the problem. Zoom in on that a little bit. So, what do I need to find?
Wait, what are you trying to find out?
How many total meters does the person swim?
I'm going to find both of the sides.
Yeah, the other two sides that we don't already have. So I'm going to label those. If this is A, that means this is side A. If this is C, angle C, this is side C. Okay? So how do I go about finding those?
We're going to need to find the third angle. I guess we need to find all the angles.
We need to find all the angles. Because right now we only know the 28 degrees. How can I find the other angles? Or do you not recognize what any of them would be?
B would be 180 minus 58.
Close. But the problem is if I do that, that's going to include from here all the way up to here. You see that?
Is that little angle right there 28?
Which little angle?
The one that's not included.
So right here?
Yeah.
Why is that? Why would that be 28?
I don't know.
Alternate interior
There you
angles. The idea, north and north-south line, north-south line are both parallel, right? This acts as a transversal, so this is also 28 degrees. It wouldn't be 58 because that's vertical angles. Okay? So that's 28 degrees, which that means this whole angle here is what? 94 degrees. Okay? Then what would this angle up here be?
Whatever those two equal.
58.
Okay, there we go.
Which if you stop and look at it for a second, that 58 there is also alternate interior to this 58. You see that?
Well, that was bad.
Okay. So, if I want to find A and C then, which, well, obviously this section's over the law of sine, so guess what? A is going to be over what?
Sine of 28.
Sine 28. C is going to be over?
Sine of 800.
Sine of what? 58.
58.
Yeah, sine of 800 would be a little bit weird. Now that's going to equal, both of them are going to be equal to what fraction?
800 over sine of 94.
Sine 94. Go ahead and find those two sides for me.
No problem.
What do you get for A?
76.5.
Yeah, 376.5 meters. What about for C? 0.1 meters. So then, how many total meters did the person swim?
A lot.
Figure it out.
All right, I'll do the math for you real quick. Like 1,056.
Anybody else get 1,056? What'd you get?
1,856.
Oh.
Who's right?
I got 1,056.6.
How'd you get 1856?
Don't you add the side C? Because he swims the whole triangle.
Does he?
No.
No.
Nope, he doesn't. Nope.
That's kind of sad. Maybe I don't know. Swam out there and didn't come back.
No, he didn't.
The way the problem's worded, it would just be the 1,056. So they swam out to B, then swam out to C, and then stopped swimming.
Maybe there's an island.
Yeah, maybe it's not.
Maybe there's an island out there. Yeah, sure. Island or a boat or something. I don't know. It's one of those dark math humor things. Because trust me, the professor that wrote the problem was probably thinking, yeah, he stopped swimming. Okay. Tomorrow, we'll take a look at the law of cosines. Now, this is a fairly quick chapter. If you look at your sheets, the quiz is a week from today. Test is 2 weeks from today.
We have Monday quizzes and tests.
Yep. It's the way it has to land to be able to get the stuff done before break and get the final, to actually have review days.
Yeah, I did that, yeah.
The rest of the time is yours.